Hello everyone, it's August the 3rd. Alright, yeah, today we're supposed to push some code to stage, but unfortunately, I've been developing the code locally for too long, and then on the master branch, it kept getting changed, so I have to do lots of testing and then handle some merge conflict. Yeah, we thought that we could push yesterday, but it lasts into today. So yeah, that's how the project is delayed, one day at a time. Things like this. All right, anyway, so today we are going to do mirror reflection. If I remember correctly, this one has a mathematics solution. Is that correct? A mathematics solution? I don't know. There is a special square with mirrors on each of the four walls, except for the southwest corner. So southwest corner doesn't have a mirror. There are receptors on each of the remaining corners. Number 0, that's a very rough drawing. The square room has walls of length p, and a laser ray from the southwest corner first meets the east wall at a distance q from the 0th receptor. Given the two integers p and q, what's p? The length of the wall. Return the number of the receptors that the ray. Wait, hold on. Return the number of the receptors. The number that the ray meets first. So this one is. Holy guacamole. If it's 2 and 1. Oh, damn. 3 and 1. Alright, my cat is meowing already. We just started. Alright. Just don't want to stay there any longer, right? I know. Come. Alright, let's do 3 and 1. What's the rule of refraction? It's the angle, the in angle is the same as the out angle. Right, so it will go here. Oh yeah, it's 1. Are PQ integers? PQ are integers. From 1 to 1000. Okay, so we have a square. We just see where did it hit, right? So if I draw, we can extend, and if we take a parallel, that's where it will hit, right? Basically, it will hit here, and then it will here, so we can keep drawing. So we do this, keep going. That's the first hit, right? The first hit will basically just extend the same, and the second hit will extend the same. But it might hit like here. Then what? Then we can still extend it, right? Then we'll hit back. I'll hit back, down, up, there, there, there. So we keep it, eventually we'll hit something. Yeah, this gotta be like a mathematics way to do this. So when I first hit, we'll keep the whole of this, right? If it's small, then we just and then if we cannot reach here, like if it's not, so to hit one, we have to go boom, 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 right? So it's like 3 steps. Yeah, it has at least 3 steps if we want to hit one. Because we go 1, 2, 3. So we have to advance upwards 3 times in order to hit one. And hit 2, we upwards 2 times. And hit 0, we probably, I'd say, I don't know, how many times we need to upwards in order to hit 0? Can we keep extending? Right? And then what? Then we will go down this way. So what does that mean? Oh, that's the same distance as this one. So we just go down. And then we go down this way. Basically, it's just is this distance. So it's the same distance. Now I go down. 4 trips to go to 0. Yeah, 2 trips, right? 1, 2 to go to 2, 1, 2, 3 to go to 1. And because go to here, we must go down here. To go here, we must go down. So it's 1, 2, 3, 4 to go here. So just divided by how do we divide? Multiplied by something. The Q is just the unit, right? So we can just Q. So we say 3 times Q and 2 times Q and 4 times Q. 2Q, 3Q, 4Q. And then we say there's a K times P. We say K times P, what is the smallest K that will make it equal to either 2Q, 3Q, or 4Q? The smallest K. Yeah, is this smallest K? No, it should be the first hit. Right? And then should equal to something times P. First time. So you're saying we iterate through? Because we just go 1 time, 2 times, 3 times, and see which one become a multiple of P. Multiple of P. So in our case, Q is 1, so we have 2, 3, and 4. Then we want to make it become multiple of 2. So we can times 1, times 1, times 1. 2 is a multiple. 4 is also a multiple. Yeah, like 1, 2. We hit here. What's next? Actually, I don't know what's next. 4 is also divisible. Hmm? How do we get back to 0? Is it 4 trips? Tell him there's a certain Q, right? that a very small queue on a very large queue. Each time we progress with P. Basically, how many times, right? How many times we need for Q. So P is a certain value. So how many times Q equals something times P. So they're not least common is the least common multiplier, right? LCM, the least common multiplier. So by finding the least common multiplier, I know how many times Q need to go. If it's 1, 2, least common multiplier is 2, so it's 2 steps. Otherwise, it's 3 steps. Okay? Then we know how many times it will bounce. And we know it takes 2 bounce at least to get a 2. Or it takes 4 bounce to get a 2. Then how do we know how many Q's are there? Well, how many P's are there? All right. How many P's are there? Like odd number go to 1. Does that make sense? Because to go to 1, we have to start from here, right? And if we start from here, if I just go here, so we have to start from here. So I always take 2 to go here. 3, 4, 4, 5, 6. I go to 2. And I go to 1 is like odd number. What if we like shooting in here? I take 1, 2, 3, 4. Right? 1, 2, 3, 4. 1. 1, 2, 3, 4. So always take however many, and then we always take the last one will be 4 to go. So it will be the 4th stroke to go down to 0. You'll always be going from here to 2nd, 3rd, right? And then before that, we can do 1, 2, right? 1, 2. Could be 1, 2, 3. Could be however many. And eventually, if we start counting from the upwards, there will always be 2. So before that, it's like if I find, so I know how many bounces there are. If I know how many bounces there are. Can we say always take 4, 1? No, we can't. We can't say always take 4 steps to go a direction. I was trying to figure out like if there's a certain way to say, oh, if we take this direction, it must after a certain number of steps. But that's not. Like if it's within, right? You can go many, many steps, like to hit 2. It'll be always even, right? To hit 2. It'll always be odd to hit 1. But after this, craziness, right? We'll always take like the last one we hit there, right? If it hits back on the left wall, then we'll just continue until at a point when we hit, we'll hit the top wall. And then I'll take 1, 2, 3, 4 to start again. So it'll be ba 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 ba, and then 4, right? And then the fourth one will be 1 to hit 0. So if I do the least common multiplier, smallest common multiplier, right? Which I think is Q times, isn't that P times Q divided by their largest common divisor, LCD. I think that's that. And we can use this to divide it by, like, is that right? We can say P is, I don't know. Let's say P is 15. Q is 12. How about that? And then we can say math.lcd. No. Oh, I can do LCM direct. Oh, greatest GCD. LCM, they have LCM. It's 60, right? Which is 15 times 12 divided by, pretty sure it's 3. Yeah, so it's 60. So we say 60 divided by Q, right? Now we have 5. So we'll go 5 times, because it's an odd number, so it will be 1. Actually, we can test our hypothesis on here. Say 15 and 12. We say that shall be 1. Oh, that's a 0. What? What? That's not right. The hypothesis didn't work.
Mm.
Zero. Oh, what? 1, 2, 3. Unless I'm mistaken on this, how does that happen to 0? Or we can say that's 60 divided by P. So basically, this one I advanced 4 times. That's not helping. How is it possible? I don't know, man. It's not LCM. Tell me what it is. What's 3 and 2? Is that 1? Oh, it's a 0 as well. Man. It is 0. But you advance it 4 times. How is it possible? I'm really struggling this one. What is the rule here? So I advance 2 times, right? And I want to advance another 2 times, but I don't have enough, so I advance 1 time. Okay? Then the next one I need to advance 2 times, but I need to pay. I need to pay back because previous one I have a debt. So I erase the debt, so I advance 1 time. And then I advance 1 time. And then we hit. So we go up and down. And we hit here. Advance 3 times. Well, what is hitting the opposite side then? 2 times going over. If we don't go over, but we hit, then we'll be on this side. If we go over, whatever over I say, it's a debt. The next time we add, we remove the debt, and then we advance, then we're going down, we're going backwards. Right? Going down. And then it's the same process. We advance, and if we hit, hold on, what are you saying? What I'm saying is I advance and advance, right? I keep advancing, and if I, in the even advance, if I hit, right? If in the even advance going upwards, then I hit 2. Odd advance, then we hit 1. And down on the way down, okay? On the way down, same thing. What on the way down means, it just means we start from the top floor, right? And then we're going that way. Or we're going this way. Is it possible to go? No, I don't think it's possible. I think it's always going in counterclockwise. So we just say on the downside, it has to initiate from the top. So I go 1, 2, will be an even. So in this case, we have P is 3, Q is 2. So I advance 2, and then I want to advance another 2, but I can't. So I advance only 1, I have remaining is 1, right? So remaining 1, which means when I hit the top, I'll have a debt of 1, right? Then I'll go down, and then go down the first one, will cancel the debt. Now we have 1, advance 1. So we have 2 remaining, right? And then I use 1 step to hit. So the initial position, right? Initial position is 0. Initial position, and then initial position is always 0 going up, and the first step is 2, right? And now in this one, initial position is 0, and the first step is 1, right? And then first step is 1. Then we say if the remaining is divisible. If it's not divisible, if it is divisible, then we can calculate how many steps. If it's not divisible, if it is divisible, right? If it is not divisible, then we have a remainder, and then we can calculate the next initial step. Okay, let's use this rule to try the 15 and 12. So with 15 and 12, we do what? 15 divided by 12. So remainder is 3, which means the debt. So we do 12, right? And if we do another 12, then we cover 3, and the debt is 9, right? We have the debt is 9. So the first, so we go up, debt is 9. Now we go down, first step is 9, then we have 3 left, right? And then we divide by 12, and the remainder, what's that remainder? So it will be the last one, right? It will be smaller. So that's 3, it's smaller than 12. So we will stick out 8, right? Now we go up. Now the first step is 12 minus 8. First step is 4, right? And then we have 11 remaining, right? 11 remaining. Now 11 remaining is small, so we will stick out 1. Right, so that's the, wait, hold on. So we have 11 remaining, and then we do one step, and then we do one step, and we stick out 1. Right, so 1 is the debt. Wait, hold on. Let's do it again. We go 12, so we go up. We do however many we can, and the remainder is 3, right? So remainder is 3. That means we can do however many we want, and we have 3 remainder. So we take the 3, so we have a debt is 9. Okay, so now we start with 0. So we start at 0, but debt is 9. Now we go down. Start is 12 minus 9 is 3. Okay, then we have 12. Ooh, debt is 9. We go up. The debt is 9. So we just overshoot by 9. So when we come back, we cover the 9 and we start with 3. Okay, so now we have 12 remaining. And then we hit. And then we hit. So the first start is 3. That's one step. And then 12 divided by 12 is 1. So one step, then we hit. So when we're going down, and then we have basically 2 steps. 1, 2. Then we hit 0. Ooh, this might work. That's a bit convoluted, but I don't know. Give me some other numbers. Say 5. How about 5 and 2? Let's try 5 and 2. So 5, P is 5, Q is 2. So we go up. Start is 0. Okay? So 5, 2, a remainder is 1. Right? Remainder is 1. So the debt is 2 minus 1 is 1. I'm going down. The first step. Oh. So starting number of steps is 0. So number of steps is 0. Right? So now first the starting position, because we have debt is 1, so the starting position is 1. Right, now we have 4. 4 divided by 2, we can divide, so we have 2 more steps. So it's 3 steps. What does that mean? Doesn't matter. 2, 2, boom. Oh, shoot. That's a different situation. I think that situation is different. Yep. I think that is 0 as well. Because we go down, we hit it. Okay, because there's no mirror here, and so which means if it hits this is like, how do you bounce? You cannot bounce. So we can say, actually we cannot say, right? It depends on how many steps it takes to go to the top. So like in this one, 5 and 2 go up because we actually hit the up. So it's like 1, 2, 3, right? 3 steps, we go to the top. Because it's 3 steps, say 3 steps to top. And what's the other one? 3 and 2, right? 3 and 2, we take 2 steps. 1, 2, 2 steps at the top. So if it's even, if it's odd number hit the top, then we say odd number going down will hit 0. But if it's even number hit the top, then it shall be even number down will hit 0. Because if it's odd, 1, 2, 3, and then boom, boom, 2 steps go down. So it's in, wait, hold on. No. 1, 2, 3. Right? 1, 2, 3, 4, 5, 6. Yes, 1, 2, 3. So odd numbers up, 4, 5, 6. Odd numbers, so we have 1, 2, 3. It's odd numbers going down. Okay? If it's even number, go up 1, 2, 3, 4. So it's even number go down. Okay? And how about 2 and 1? I think 2 and 1, it doesn't matter. Because the array coming down, it could be, if I'm here, it could be do, do, or do, do, do. I have 2 different ways coming down. But going up, it's either, like, could it be this way? Can we go this way? Is it possible to go this way? That's the thing. I don't think, like, how. I really don't think it's possible to shoot up. So it's always like parallel. It's either this or this, right? So from here, it's always going to go this way. And the reason we shoot here have multiple ways because we can go down this direction, right? Or go down. Yeah, they're all the same. It's just either this, go down this way, this way, this way, 3 steps. Or go down this way, this way. So equivalent for this, it's either this, this, or this. So is it possible to go this way? I don't think it's possible. If it's not possible, then it has to be even number of ways for 2 and odd numbers of way for 1. So all we need to do is go through this schema, right? So just count the number of ways to go. And so we have a starting position, and we have the starting number of, if the starting position is 0, then we have 0 step. If the starting position is positive, then we have 1 step. And then we have the remaining value, and then we do a mod, right? We do a div mod, how many? And then we will plus 1, right? And then we'll have the remainder, and this minus remainder is the det. And the next one coming in will be minus this det. If you minus this det, right, next one minus the det, then it's just the remainder from the previous one, right? It's just the remainder from the previous one. Yeah, it's just a remainder from the previous one. So we get a remainder, which will be the starting position for the next one. Okay, let's try. It's been an hour. Man, this one is hard. Well, if this doesn't work, I might consider just give up on this one. It take way too long. So here's the idea, right? We have a starting position, call it 0. And then I'll go a while true loop. So what we're gonna say, the starting position, then we say p minus the starting position and count, number of steps is 0. That's when we start, right? Now we shall get the count here. So we say count equals 1 if s else 0. That's the count. And then we say this div mod, right? Div mod this with q. So this one will give us the number of, let's say, additional count and s, because the remainder is the starting position of the next one, right? Then c, I say plus equal to additional count. Now we say if s is equal to 0, oh, we also need to count if it's going up or go down. So is up is true because we're going up initially, right? If s equal to 0, then we say if s is 0, that means we have it's divisible, right? So if is up, right? Then we say return 2 if c mod 2. Well, actually return 1 if this, else 2. Else now go down, we can just go else because I think go if it's going down and we hit, it's definitely just gonna return 0. Okay, so that's if s is equal to 0. Now if s is not equal to 0, then we go back up, right? And it's c will equal to, pretty sure I can just say, oh yeah, I can just go c is 1. Oh, c is not 1 though, because the initial c is 0, so I should do it here. If s equals to 0, then do this, else c equals 1, because that's the starting position of the next one. And is up equals not is up. Like this. 2 1 2 3 1 1 5 2 0 15 12 0. What's 3 and 2? Yeah, 0 as well. Oh my god, that's 0 as well. Variable c is referenced before. Of course, s equals c. Oh my. We can say return 0 if not is up, else 1. Be like this. I need some random numbers so I can test this. Okay, let's generate some random numbers. What do you think? 1,000. Oh, we can do like, you know, like edge cases, 1 1, things like that. 1 1 is a good one. Okay. From random import randint. Let's generate like 10 test cases. Put this in range 10. Okay. We say while p equals q equals 1. So while p is larger than q. Well, no, while p is smaller than q. Okay. P equals rand int 1 to 1,000. Q equals rand int 1 to 1,000. Actually, P equals 0, Q equals 1, so P is smaller than Q. So we blah blah blah. Once we're done, we say print P, print Q. Okay. So I have this list of numbers. If this can pass, then I think we have a good shot. Ugh. First one doesn't pass. Output 0 0 0 0 0 0 0. What the heck? The heck is this? Why, seriously? Okay, let's go smaller. Let's go 5. See if anything is wrong. Very wrong. Second one is wrong. 4 3. The logic is not right. Damn. So 3 expected is 2. Let's see. We have 4 and 3. So P 4, Q is 3. So going up, all right? This is 0. What's the debt? So we go 3, right? Oh, did you not consider? Does it matter? Oh, it does matter. Hold on. We go here, 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 and here. Then we go the reverse style. Yes, we go this, 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 and boom. We start from here, we go reverse style. Ah, I see. So we have to consider if it's oh man. Let's just go through the logic. So go up, we have 1. So if we do, we do +1. Wait, hold on. So we go up 1, right? Div mod is 1, remainder 1. But actually, count step is actually 2, because 1, 2, we reach the top, right? 2 step, we reach the top. And then that is 1, so we start that one, go down, s shall equal to 3. Oh, that seems to be the logic is not right. So we're going down. Oh wait, hold on. We're going down, s is 3. So the remainder shall be p minus s is 1, right? P minus s is going to be 1. So the step is also still 2 step, right? 2 step. Then remainder is 1. So the next one going up, start will be 1. And then we go divided equal to 0. Yeah? How is it 0? That is interesting. But first of all, this I think it should be count. The first count doesn't matter, right? I think C is not necessary. First step, I go up. I have 1 remaining. Second one, that's the starting position. That is the det. Okay, that's the det. And it's Q minus the det. Q minus the det. So it's Q minus the det. Q minus the det. So that's the starting position. So I shall say this is the det. So div mod is the det. No? Oh, it is. Wait, hold on. No, that's not a det. That's the remaining. Div mod give me the remaining. Right? That means we take one more. The remaining, the det is this, is Q minus this. Q minus the remaining is the det. Wait, hold on. We have 4, right? And then we cover 3. And then we take another one. Then we have 1 left. So the det is 2. Right? The det is 3 minus quotient. It's 2. So the next time when I go 3. No, I'm confused. Yeah, I think this model is not right. That's 1 over 3. And now we're going down. Now we end this triangle. So it is 2, right? So we accumulate that 2. That's advancing. Those are erased, so we have 1. When we go down, we're going to cancel 1. Cancel 1. That's the one we need to cancel. That's the one we need to cancel, which is the remainder. The remainder needs to be cancelled. So it's just the remainder. Remainder needs to be cancelled. That's right. I don't have count, which is just 1. But count into plus 1. That's the remainder. So if remainder equals okay. But I still have a doubt about going up. Nah, I don't need this then. Oh, I do need this, because the first R. A lot more correct. So useless. Got it. Yeah, I know. I think I know what this one. This one's just when you hit the bottom, is it going this way or going this way? Oh man. So going down, I say I don't worry because it would definitely work. It's just going up, right? So when we go up using no. What we're worried about is going down. Hold up. So if we're going up, it's 1, 2, 3, 4. If it's even number going up, then going down, no, 1, 2, 3. Or 1, 2. So the number going down. It's the number going down. If the number of steps going down, so if it's not, how do we say this? If we have even number of steps going down, so 1, 2, 2. Hold on. So we can have either this, right, hitting this way, and then we still have 1, 2, 3, or 1, 2. Or we can have, and we have 1, 2. Or we can have 2, 3. Wait, hold on. What we say, if it was going this way, okay, then even is 2, odd is 1. If we go up this way, then even is 1, odd is 2. Okay, so we need to distinguish which way that goes up. Now it will go this way if we hit it this way, right? We hit it this way. How can we hit it this way? So either this, hit it this way, or hit it this way. So it depends on going up. Right? It depends on going up. So if go up, so if we go this way down, if we hit this way, and then we'll hit this way if it's even, and we'll hit this way if it's odd. Okay? If we going this way, then we hit this if it's odd, this if it's even. Then we have this way, 1, 2, right? So if we hit this way, then we'll hit this way if it's even, this way if it's odd, right? Then we hit this way. 1, 2, 3. Then we hit this way. Okay, so this was the start. When we started going this way. So if we go even up, then we will hit this. If we go odd up, then we hit this. And then we need to keep track going down. If it's even, then we're going this way. If it's odd, we're going this way. Oh my God. So we need up and down, right? And we say the number of steps. So we actually like to do C plus equal 1, right? C plus equal 1. What's C plus equal 1? That's the number of steps actually taken. Actually, hold on. That's just C underscore. Okay. Let's say C equals plus equals, or C underscore plus 1. Otherwise, C underscore always equal to 1. That's the additional step. Okay, that's the additional step. Okay. And then, let's not consider this yet. Let's consider r is not equal to 0. Okay. Then we need to consider the direction. Man, what direction? So we're going up, right? So we're going up. I need to check if the direction, and we know the next direction. So we can say, I want the next direction, right? I want a direction, dir. I would say, so current, what can I just say, direction equals upper right. So upper right, lower left, like this. Upper right, upper left, lower right, lower left, right? So we say if direction is equal to upper right, right? And then we say, it's actually going to be C. If C, if the total number of steps is odd, then the next direction shall be, which means it's 1, 2, 3. Next direction is going lower right. Else, next direction is lower left. Okay. Aleph direction is equal to yeah, we can actually do all of them. How about upper left? If the direction is upper left, then 1, 2. I say C. Oh, why don't you say dr equals lower right if else lower left. Right? I say direction will equal to, so upper left, 2, 3. So lower left if C else lower right. Aleph dr is equal to lower left, okay, lower right. If we use lower right, then upper left if it's lower right, 1, 2, 3, upper left else upper right. Aleph dr is equal to lower left, right? Then dr equal to upper, it's lower right. 1, 2, upper left, okay? No, that's not upper left. That's upper right, my bad. It's upper right. This is upper left. Odd. 1, 2, 3. Wait, hold on. 1, 2, 3. What the hell? Come on. Upper right. If it's odd. 1, 2, 3. We go lower right. Okay. 1, 2. We go lower left. That's good. Left. That should be opposite. Lower right. We go 1, 2. So it's even. We'll go upper left. 1, 2, 3. Upper right. Yes. So if we hit lower left, So 1, 2, 1, 2, 3 will go upper left. Upper right. So that's the direction. And the original of this one would be this, and we don't need this one anymore. So I do a div mod still. Okay, so now we can say if direction is equal to lower left or lower right, we're going down. Actually, it's actually, I think direction. The initial direction. Doesn't matter. Right? It doesn't matter. As long as it goes low, then we return 0. Right? And now we say if direction is upper left. Right? So direction, now let's go upper right. That's what we're familiar with. If it's upper right, then 1, 2. And C equals 0, then return 2. If dr is, so that's one situation, or direction is upper left. So upper left, 1, 2, 3, I go 3, and C, right? And if dr is equal to upper right, and C, or dr equal to upper left, 1, 2, 1, 2. So this condition will now return 1. Let's try this. Invalid syntax. Of course. All right. All right, let's try this. All right. Man, this is very random. All right, I think this one will be right. Come on. Oh, damn. Damn. 1 hour 44 minutes. Oh, Lord. Oh, have mercy on me. My God. Look at the previous solution. So much nicer, huh? Let's take a look at both. And what's the passing rate? The passing rate is very high, 60%. It's supposed to be an easy problem. But I thought this is going to be an easy problem. But I got stuck for 1 hour and 45 minutes. It was just so complex, so convoluted, right, in my head, and I just couldn't make sense of it. Now, the final solution is very complicated, and I'm sure the actual solution is very simple. But anyway, so this solution uses div mod to compute the number of steps taken, right? Number of steps taken to to advance either upwards or downwards, right? Upwards or downwards. And the distance actually, and the position of the laser in the next, I shouldn't say position, yes, the position of the laser in the next, the starting position, right? The starting position of the laser in the next round on either the left or right wall. Now the complication, right? Complication is that depending on the direction of the laser movement and the parity of the number of steps, the destination corner changes. Yeah, but that's just how the solution is. We're gonna have to investigate how the other problems, how other solutions are. It seems to be very simple for, I don't know. Yeah, it happens. That's today's solution, 69 test cases. Damn. Same number. It is the same. Okay, we're gonna go refer to this thing. Should I end it now? I mean, I could have made it easier, like we can make a dictionary. So the logic will still be there. I mean, maybe we can make a dictionary so make it a bit easier to, like, we can dr equals, like we can say this and 0, 1. Yeah, we can say next dr equals dictionary with ur 0 and 1. 0 will be lr. No, 0 will be ll. lr. Right? You know what? Let's do a solution 2. Say use dict to codify the rules for next direction and final checking. So next dr rule, if the previous dr is ur, then you will have ll and lr. If the previous is ul, then you will have the reverse. if the previous direction is UR. No, I have done UR. LR. LR, then it's UL and UR. And if it's LL, now I reverse it, UR, UL. So that's the next, and then this is checking, right? If it's LR, that will be 0. LL, that will be 0. If it's UR, then 2, 1. If it's UL, that shall be 1 and 2. So just return checking dr direction and C2. And this dr equals next direction rule drc. Int object is not subscriptable. Oh, shoot. My bad. Yep, so this is use a dictionary. It's not going to be any better, but I like to put it there. Slightly faster, so if else is very expensive, I know. Better performance because we avoid a lot of if else. Oh, that's the most I want to extract out of this. See, I was drawing this, but for whatever reason I couldn't figure out. I might have left a comment here. First, second. Yeah, but how do we go from here? M is the number of room extension plus 1. N is the number of light reflection plus 1, okay? If the number of light refraction is odd, so 1, that should be, which means N is even. Corner is on the left hand side. As well, corner is 2. So you think about this as, wait, hold on. If the number of refraction is, if a light refraction is odd, one reflection. So we land here. We extend the room. So it's like we flip up. So this becomes 0. And we flip up. become 1. So if the reflection is odd, that's going to be here. If the reflection is even, then if the number of room is odd, even, then that's going to be 0. If it's odd, that means it's going to be 1. Ooh. If m is no. If n is even, that's always going to be 2. So n is even, it's going to be 2. If n is odd, m is even, it'll be 0. So now we need to find m and n. Yeah, that's just the LCM, right? It's just LCM. Well, the LCM divided by. Yeah, that's right. So I say P is, K is the number of rooms. M is stacked extended. How is M is the stacked extended rooms? I don't want to be confused by this. Solution 3. LCM is P and Q. Okay. So P is, so M shall equal to two rooms and 1, 2, 3. Yeah, so P is 3, Q is 2. Right? So the number of reflection, reflection shall equal to LCM divided by Q minus 1. Number of room cm, right, divided by p minus 1. No, I think this is just divided by p, because it's going to be 6, right? 6 divided by 3 is going to be 2. But 6 divided by 2 is going to be 3. The number of reflections, because 1 reflection, 2 reflection, we hit there. So 2 reflections, actually 3 reflections. Number of rooms. So I have 2 rooms. So we say if the reflection number is odd, right? We say if num reflection, then we're going to return 2 because it's odd. So we always, 1 reflection always end there. But if it's even reflection, then we shall return. If it's even reflection, then we say the number of rooms, right? If it's 1 room, so we say to return 1. If number of rooms is odd, else return 0. Is that right? I'm not confident on this one. It looks slightly different from. Let's try this. Yeah. So inspired by. So it's slightly different from what this one is. That is not right. They say M is number of room extension. I don't want a room, I want a total room. That's why we don't minus 1. So this is the least common multiplier. Number of reflections. Number of total rooms. Original plus extended. Odd reflections always ending on the left side. Even reflections depending on the number of rooms. Each even count of rooms can be thought of as the original room flipped upwards. Hence, hence the top right corner of an even room represents 0. Okay. Oh boy. Let's try. See, this is pure. This is IQ. I count this as IQ. Still solved it, but man, 2 hours today. Alright, I'll see you guys tomorrow. Adios.